The mass of the Sun is almost 2 octillion tons. That's 1.989 times 10 to the 27th power, which is equal to 99.8% of the mass of the entire solar system. It's simply unreal to imagine even 1/100th of this incredibly huge number. Nevertheless, in the Homburg 15A galaxy, located at a distance of 700 light-years from the Earth, there's an object that our Sun, in comparison, would look like no more than a small speck of dust. At first glance, it seems that what we see in this image is nothing special. However, in the very center of this galaxy is a black hole whose mass is 40 billion times greater than the mass of our Sun. How did such a giant black hole form, and what can it tell us about our future? It all started in the summer of 2019 in the northern part of Chile at the Paraíso Space Observatory. For 2 nights, a team of astronomers using the multi-unit spectroscopic explorer on the largest telescope in the world watched the movement of stars in the Homburg 15A galaxy. Scientists discovered that all the stars revolve around a monstrously huge object. Through complex calculations, astronomers learned that this object is a supermassive black hole. Initially, researchers measured its mass indirectly by studying the dynamics of objects directly inside the galaxy, as well as by the movement of adjacent galaxies. According to these indicators, the black hole turned out to be 310 billion times more massive than our Sun. Then the researchers used the Schwarzschild metric, the only mathematical method to date that allows for the accurate measurement of the mass of a black hole. The resulting number turned out to be slightly smaller, but still pretty impressive. According to this more accurate data, this black hole has a mass 40 billion times larger than the Sun. The event horizon of the black hole discovered in Homburg 15A exceeds the orbits of all the planets of our solar system combined. It's very difficult to imagine such an impressive scale, but we'll try to do it. In order to imagine the size of such a black hole, you can mentally superimpose it on the entire solar system. The distance from the Sun to Pluto averages 39.5 astronomical units, which doesn't even cover a tenth of the radius of the black hole. The distance from the Sun to the Kuiper belt is 50 astronomical units. This is still small compared to the black hole. Heliopause, the place where the solar wind ceases to have any effect, is 123 astronomical units from the Sun, which compares to just 1/8 of the radius of the black hole, which measures about 790 astronomical units. Only the distance from the Sun to the outer boundary of the Oort cloud, which is equal to 1,000 astronomical units, is capable of completely spanning the radius of the black hole. Accordingly, the diameter is equivalent to approximately 2 solar systems. As for the 40 billion masses of the Sun, with such an immense size, this is not too much. Nevertheless, according to scientists, such a mass is near the potential size limit of black holes. According to calculations, the maximum possible mass of a black hole cannot exceed 50 billion solar masses. An exception may be just in those cases where 2 extremely massive black holes merge to form one black hole with 100 billion solar masses. Before exploring the Homburg 15A galaxy, TON 618 would consider the largest black hole. Scientists initially calculated that its mass was equal to approximately 66 billion suns. However, these indicators were calculated indirectly, so in reality, the accurate measure of the mass of the TON 618 is much smaller. The black hole from the Homburg 15A galaxy still turns out to be the record holder. However, one more question remains. How could such a monstrously huge object appear in our universe? Scientists suggest that it arose as a result of the merging of 2 Euler-type galaxies. Both galaxies had depleted nuclei, that is, there were a fairly small number of stars. This type of merger, according to researchers, is very rare and usually gives birth to such giant monsters. However, researchers can't rule out the possibility that there were more than 2 galaxies. Perhaps several of them had supermassive black holes in the center, the merger which formed the largest black hole discovered to date. No matter how huge the black hole is, it may seem to us that this has nothing to do with humanity. However, it's likely that the black hole is able to tell us a lot about our future. Indeed, in fact, such a merger of galaxies could be awaiting the Milky Way in the future. After about 4.5 billion years, our galaxy will collide with Andromeda. The first evidence of this inevitable event has been available for a long time. As early as the beginning of the 20th century, the astronomer Vesto Melvin Slipher drew attention to the fact that space objects differ in the color of their glow depending on their motion relative to the Earth. Objects that move away from the Earth have squeezed light that shifts toward the red color of the spectrum. Approaching objects, on the contrary, emit blue squeeze light. The Andromeda galaxy shone exactly in blue. Based on these data, in 1913, Slipher calculated that Andromeda was heading towards a Milky Way at a speed of 186 miles, or 300 kilometers per second. For decades, scientists could not understand exactly how this collision would take place, whether this would be a destructive head-on blow or whether the galaxies would simply brush against each other remained a mystery. Of course, it was absolutely necessary to solve this problem since the future of mankind could depend on the answer. In recent decades, researchers have finally given a clear answer to this question. Thanks to the observation of the paired galaxy NGC 6052, which was formed as a result of the collision of two other galaxies, researchers carefully studied the images taken with the Hubble telescope and made predictions about the Milky Way. No matter how powerful the collision is, the Sun and other stars, as well as planets, will survive because there's a huge distance between them, tens and hundreds of light years. Most likely, not a single person will remain on Earth by that time since the Sun will begin to turn into a red giant before this takes place. Mankind, which most likely will have populated other planets by that time, will be able to observe many interesting phenomena. As it gets nearer, the Andromeda galaxy will appear larger in size, resembling a huge lightsaber in the sky. By this time, the giant molecular clouds, which are our stellar nurseries, will begin to shrink, thereby forming many new stars. In turn, the stream of stars forming the Milky Way will be destroyed and mixed together. Gas, dust, and new stars will completely remake the night sky that we see now. Many of the emerging stars will have enormous mass and will exist for a very short period of time before exploding as supernovas. If by this time humanity still survives, it will be near new stars, but subsequent explosions may bring an end to the existence of our civilization. But I think that scientists of the future will surely prevent settlement near such dangers. Later, the Andromeda galaxy will go further beyond the Milky Way, but after 100 million years, it will make a U-turn and merge with our galaxy again. This will initiate another compression of molecular clouds and the birth of more new stars, some of which will burst into supernovas. As a result, Andromeda and the Milky Way, two spiral galaxies, will turn into one elliptical galaxy. Scientists have already given a name to this future galaxy, Milkdromeda. But the most important thing is that our solar system may end up far beyond the borders of this newly formed galaxy, though perhaps this might be better, given that a collision of galaxies can form a supermassive black hole, as in the case with the Homburg 15A galaxy. At this point, there will be a supermassive black hole in the center of the Milky Way with a mass of between 2 to 5 million solar masses. In the center of Andromeda is a candidate for black holes with a mass of 140 million suns. This is not enough for a record, but we still don't fully understand the formation process of such giant black holes. Another question: can the solar system exist as it did before but now outside the newly formed galaxy, Milkdromeda? After all, then the whole balance of gravitational interaction with other cosmic bodies will be upset. But we'll explore this question another time. If you like my video, give us a like, subscribe to the channel, and click on the bell so you won't miss notifications of new videos. And don't forget to invite your friends. It's much more fun discussing these exciting and interesting topics together.